Hey everyone, today we're going to be talking about the distributive property. The distributive property states that a number or variable expression can be multiplied by a sum or difference. Okay. In numbers, that's going to be something like 3 times 4 plus 5, where this is equal to 3 times 4 plus 3 times 5. In variables, that's going to be as if I had some variable plus something times something plus something, and then I can do the same thing. I can show that A times B plus A times C. In example 1, we are going to be using numbers, so being able to break down numbers in order to multiply them after we have created a sum or a difference. So, for example, this 3.5 is going to become 3 plus 1/2. So I'm going to write this as the distributive property, 8 times 3 plus 1/2. So I just broke the whole number apart from the fraction. So then I'm going to do 8 times 3 plus 8 times 1/2. 8 times 3 is 24. Half of 8 is 4, and 24 plus 4 is 28. Now these ones are going to have a single number answer because everything is a numerical expression. I'm still following the order of operations, so my multiplication comes first after I break those things out of parentheses. So I'm actually distributing this 8 to each thing. Okay. So this one, 12 1/4, is 12 plus 1/4. So I'm going to break this down as 12 times 12 plus 1/4. Now, when we did order of operations, we would do our parentheses first. But now that we know the distributive property, I can distribute to those two things inside the parentheses. So here, I'm going to have 12 times 12 plus 12 times 1/4. 12 times 12 is 144 plus 12 times 1/4 is 3, so 147. Now for this last one, there's a couple different things that you can do with 78. If you want to use addition, you can do 70 plus 8. If you wanted to do subtraction, you could do 80 minus 2. Both of those things equal 78. There are many, many other ways that you can add or subtract to get to 78. These are just the two simplest ways because I create something that has a 0 and then I use the extra number. So I'm going to show this one both ways. So I've got 4 times 70 plus 8, or 4 times 80 minus 2. So I've got 4 times 70 plus 40 times 8, or I've got 4 times 80 minus 4 times 2. So this is going to be 280 plus 32, or 320 minus 8, and both answers get me 312. No matter how you break down that number, you should get the same answer. Now again, these ones have a single numerical answer because they are numerical expressions. Previously, we had done these using the order of operations, combining the thing in parentheses and then doing the multiplication. But now we're trying to use that distributive property. So we're trying to break down those numbers and then distribute that multiplication. Example 2, we're going to do it with variable expressions now. So I'm going to be distributing this 2. And you'll see that I've got significantly less lines. And the reason why I have less lines here is because I'm not going to be able to simplify my algebraic expression the way that I did the numerical expression. So this is going to be 2 times x plus 2 times 3. 2 times x becomes 2x, and then I'm going to multiply these two together and I get 6. Now at this point, this expression is completely simplified because 2x and 6 cannot be combined together. They are not like terms. One has a variable and one doesn't. In number 2, now I'm multiplying an 8 times a 2x, so it's 8 times 2x plus 8 times 3. 8 times 2 is 16x, and 8 times 3 is 24. So this would be my final answer. This one I'm back to just a single x, so 5 times x plus 5 times 9, so 5x plus 45. And then down here at the end, this one is just like number 2, 3 times 5x plus 3 times 4 is going to be 15x plus 12. And again, these are algebraic expressions at the end because I cannot combine anything. 5x and 45 are not like terms. 15x and 12 are not like terms. One has an x and one doesn't. Now we're going to add in the negative integers. So we've been working with negative integers, operations with negative integers. So we are going to continue that. So we're going to add an example with negative integers. So I'm going to show my distributive property. So this is negative 4 times x plus negative 4 times 5. So I'm going to have negative 4x plus negative 20. You might also see this written as negative 4x minus 20. So they represent that negative as a minus sign. And we talked about that, how it can go back and forth. In number 2, we're distributing a negative to a bunch of negatives. So I've got negative 7 times negative 2x, and then I've got plus negative 7 times negative 3. So I'm going to still represent my negative as plus the opposite. So this negative sign right here, and I'm going to zoom in a little bit, is the same thing as plus negative 3. So here's my plus sign right here, and then I represented this negative 3 right here. As long as I'm showing that I'm multiplying a negative by a negative. So then I get positive 14x plus 21, because all those negative times negatives are going to go away. In number 3, 7 times x, 7 times minus 3. So this is going to be 7 times x plus 7 times negative 3. So 7x plus negative 21. And again, I can represent that as a minus sign or 7x minus 21. These two things mean the same thing. In number 4, I'm distributing that negative 5. So negative 5 times 4x plus negative 5 times negative 1. Again, if I represent this as plus negative 1, it makes sense where the plus sign comes from. So this is going to be negative 20x plus 5. These are, again, algebraic expressions because the part with the x does not have anything in common with the constant at the end. In example number 4, we are now going to be going the other way. So we're going to be finding the number on the outside of the parentheses and then breaking down our expression the other way. So we're going to start with the two things that are going to be added together, and we're going to end with the expression that has the parentheses in it. We are looking for the greatest common factor, so the greatest common factor between 45 and 72, the greatest common factor between 80 and 56. And you can see I have the little stars there for our greatest common factors. Between 45 and 72, so 45, 1 times 45, 3 times 15, it's going to be 9, I believe. 9 times 5, 9 times 8. So my greatest common factor is 9. And the first thing I'm going to do is after I find my greatest common factor, I am going to write my two numbers as multiplication with that greatest common factor. So I'm going to write this as 9 times 5 plus 9 times 8. Okay, and then what's going to happen is the number that repeats, so this number right here, is going to go outside my parentheses. And these two numbers are going to be the addition inside my parentheses. And I want to end with this expression that includes the parentheses. So I'm going backwards this time. In number 2, my greatest common factor is 8. And again, I'm going to write my two numbers as 8 times something. So this is going to be 8 times 10 plus 8 times 7. The number that repeats goes outside my parentheses. And then my two numbers that are being added together are going to go inside. So 10 plus 7. For 42 and 28, my greatest common factor is 14. So this is 14 times 3 plus 14 times 2. So I'm going to have 14 times 3 plus 2. And then my last one here, the greatest common factor is 3. So 3 times 5 plus 3 times 6. So 3 times 5 plus 6. Okay, again, the number that is being multiplied is on the outside of the parentheses, and then I'm adding those two numbers together. Okay, in my last example, I'm going to do the exact same thing, but now I'm going to do it with variables. So between 3x and 6, my greatest common factor is going to be 3, and I'm going to do the same thing that I did in the last example. I'm going to write my two things as multiplication with my greatest common factor. So 3 times x plus 3 times 2. My 3 is still going to come to the outside. So 3 times. And then my two things that are being added together are x plus 2. Between 36x and 30, my greatest common factor is 6. So it's going to be 6 times 6x plus 6 times 5. So here's my number that's the same. So 6 goes on the outside. And then 6x plus 5. 21 and 35 have a 7 in common. So I've got 7 times 3x plus 7 times 5. Now the reason why, and I'm going to talk about this for all three of them that I've done already, the x expression, so the variable expression comes after that multiplication is because I've identified the greatest common factor as just that single number. There is no variable on my greatest common factor. That's why the variable expression is that multiplication. So this is going to be 7 times 3x plus 5. And then here the last one, my greatest common factor is 4. So this is going to be 4 times 2x plus 4 times 1. That's a tricky one because 4 is multiplied by something there when we have it in parentheses. So that 1 is extremely important. And this is going to be 4 times 2x plus 1. Okay, and we have to have that plus 1 because the 4 does exist there in the final expression. So this is using the distributive property and also factoring using the distributive property. We are simplifying numerical and algebraic expressions using the distributive property, knowing when we can combine things, knowing when we cannot, and making sure that we are multiplying by each part of the expression.